Hi, class. In this segment, which may actually run into two segments because this is always a little bit more involved than I often anticipate. But please know first and foremost that I'm going to refer back to the hypotheses examples. Now, you don't necessarily need to have this handout, which you've seen earlier, chi-square hypotheses. You don't necessarily need to have that handy because I'm not going to refer to this particular sheet directly. However, what I'm going to essentially do is use each of these sets of hypotheses, and there's 4 of them. I'm going to use each of those sets of hypotheses in order to introduce the concept of a contingency table, and also, very closely relatedly, I will also introduce the concept of degrees of freedom for the chi-square test. So that's really the purpose of this first segment, which may run into 2, is to introduce you to the contingency table and also the idea of degrees of freedom as it relates to chi-square analysis. And then later, perhaps in an additional clip, we'll discuss the chi-square table, the probability distribution in SPATs, which I think it's page 388, but I'm not sure. Let me make sure. No, 389. But we'll get to that in a little bit. But again, I'm going to use the previously stated hypotheses in order to introduce contingency tables. And contingency table is also very closely related to degrees of freedom. So first, if you'll recall, the null hypothesis for example number 1 is, and I'll just read it, sex measured as male-female is not related to, is independent of income measured as at or below the poverty line. That was one category, and above the poverty line is the other category. If we were to set up that hypothesis in a contingency table format, it would look like this. And you can see at the top here, I remind you, please refer to the hypotheses handout. Example number 1. As you can see, we've got 2 rows. This is row number 1 and row number 2. And then we have 2 columns, column number 1, column number 2. I've also, in this contingency table, I've also named the variables. Here, I've called this variable poverty, and this variable has 2 possible values, 2 possible categories, at or below the poverty line or above the poverty line, right? Yes. Likewise, I've named this variable, which is represented in the columns. I've called this variable sex, and sex has 2 possible categories, 2 possible values, male and female, okay? So we have a grid, we have a table, specifically a contingency table, and this particular contingency table would be referred to as a 2 by 2 contingency table because there are 2 rows and there are 2 columns. Okay? Let's move on to the next example, example number 2. I will refresh you regarding the null hypothesis, and then I will present the contingency table, which I've also created as handouts on Blackboard. Null hypothesis from example number 2. Class in school measured as freshman, sophomore, junior, senior is not related to or is independent of participation in extracurricular clubs, measured as yes, some participation, or no, no participation. I've set this I've created this contingency table to represent that hypothesis, example number 2. As you can see, we have 2 rows, whether or not a respondent indicates yes, some participation in extracurricular clubs, or no, no participation in extracurricular clubs. So 2 rows, and I have 4 columns representing the 4 groups or the 4 classes: freshman, sophomore, junior, senior. This would be referred to as a 2x4 contingency table. There are 2 rows and 4 columns. Now, in case you were wondering, it doesn't really matter how you set up your contingency table at this point. If we had another stats class like Stats 2 after this semester, we would get into some of the nitty-gritty about where you should put which variable if you have a situation where one variable is clearly considered an independent variable and the other variable is clearly considered a dependent variable. But for right now, I chose to set it up this way. If you wanted to set it up that way, you could, or I guess that way looks a little bit better. You could. The end result is the same. But for now, I just want to orient you to the idea of a contingency table. It is the table or the grid on which our 2 variables and their respective categories, are represented. Also, I didn't note this on the first example. There are 8 cells represented in this table. We can count them: 1, 2, 3, 4, 5, 6, 7, 8. And each cell represents a different combination of categories. This cell would have freshmen who report participating in extracurricular clubs. This cell would contain sophomores that report not engaging in extracurricular clubs. This cell would be juniors who say, yes, I participate in extracurricular clubs. This cell would be seniors that say, no, I do not engage in extracurricular clubs. Okay, so 2x4 contingency table, 8 cells. Let's move on to example number 3. Example number 3 hypothesis, just as a refresher, the null hypothesis: city measured as KC-Mo, KCK, Independence, Wichita, Lincoln is independent of unemployment measured categorical data, remember, categorically, as below the national average, at the national average, or above the national average. So how would that look in the contingency table? It's right here. We've got 3 rows representing the 3 categories of this variable: average unemployment, below the average unemployment rate, at the average unemployment rate, above the average unemployment rate. Those are our 3 rows. And likewise, we have 5 columns, which represent the categories of city: KC-Mo, KCK, Independence, Wichita, Lincoln. This would be referred to as a 3x5 contingency table. There are 3 rows and 5 columns and 15 cells. And it's probably pretty apparent, but I'll point out a couple. Each cell represents a combination of categories for the 2 variables. This cell would be KC-Mo, citizens below the poverty line. Below the unemployment rate. This would be Lincoln, Nebraskans who are above the unemployment rate. This is independents who are at the unemployment rate, and so on. Okay? So 3 rows, 5 columns for a total of 15 cells. I'm going to cut this one off and then continue.